Have you ever seen something that just looks like it was pulled straight out of a sci-fi movie? A substance that's definitely solid but looks like it's made of, well, almost nothing. This is aerogel. And as we're about to see, it really is the impossible solid. I mean, just look at it. It's so ethereal, almost ghostly, right? It's no wonder it's got nicknames like Solid Smoke or, my personal favorite, Frozen Smoke. You feel like you could just wave your hand right through it, but you can't. And that hazy, smoky blue appearance, that's our first big clue that we're dealing with no ordinary material. So what makes this stuff so strange? Well, for starters, it's one of the least dense solids ever created. To put that into perspective for you, some aerogels are over 1,000 times less dense than glass, even though, get this, they're both made from the same base material, silica. It's a solid that barely outweighs the air itself. Now, you're probably thinking that something that light must be incredibly fragile. And yeah, it can shatter, but it's also shockingly strong. This tiny piece of aerogel here weighs just 2 grams, yet it's holding up a brick that weighs 2.5 kilograms. That's over 1,200 times its own weight. It's this combination, being feather light yet structurally strong, that just makes it feel so impossible. So what exactly is this stuff? How can a material be both ghostly light and incredibly strong at the same time? Well, to understand that, we need to look at what it's made of. Or maybe more accurately, what it's mostly not made of. Right. Here's the secret to aerogel's bizarre properties. It isn't in the solid part at all. It's in all that empty space. This is a material that is almost entirely nothing. You know, the name aerogel pretty much tells you the whole story. You start with a gel. Think of something like Jell-O, which is basically a solid web holding liquid inside. Then you have to figure out a way to pull all that liquid out and replace it with a gas, usually just air, without the solid structure collapsing. What you're left with is the delicate, solid skeleton of the original gel. And just look at how much of it is empty space. A typical block of silica aerogel is 99.8% air. Only a tiny, tiny fraction of what you're seeing is actually solid material. You're basically holding a 3-dimensional web of silica that has trapped air in billions of microscopic pockets. And the story of its creation is almost as strange as the material itself. It was invented way back in 1931 by a chemist named Samuel Kistler, all because of a bet he made with a friend. He bet he could take the liquid out of a jar of jelly and replace it with air without the jelly shrinking. Well, he won the bet, and in the process, he invented aerogel. So how did Kistler do it? And how do scientists today pull off this magic trick? How do you remove the liquid from a gel without it just collapsing into a dense little puck? The whole thing starts with what's called the sol-gel method. First, you mix some chemicals to create a sol, which is really just a liquid with tiny solid particles suspended in it. After a while, these particles link up, forming a solid network that traps the liquid inside. And bam, you've got a wet gel. That part's actually pretty straightforward. The real challenge, though, is the final step. And here's the secret recipe for making aerogel. If you just let the liquid evaporate normally, the surface tension would pull on that delicate solid structure and just cause it to collapse. So the genius solution is something called supercritical drying. You put the gel in a pressure vessel, and you crank up the temperature and pressure way beyond the liquid's critical point. At this stage, it's not really a liquid or a gas anymore. It's a supercritical fluid. Then, when you release the pressure, the fluid turns directly into a gas, completely skipping the liquid phase and its destructive surface tension. The fragile structure is left perfectly preserved. Okay, so we know what it is and how it's made, but this intricate, air-filled structure gives aerogel some truly remarkable abilities, what you might even call hidden superpowers. Its first and most famous superpower is its incredible thermal insulation. Because it's mostly trapped air, which is already a poor conductor of heat, aerogel is one of the best insulators ever created. We're talking up to 39 times more insulation than the best fiberglass. You could hold a blowtorch to one side of a thin piece of aerogel and it would barely even get warm on the other side. It's wild. The science behind this is called the Knudsen effect. See, heat normally moves through a gas when its molecules bump into each other. But the pores inside aerogel are so incredibly tiny, we're talking nanometers here, that the air molecules are essentially trapped. They just don't have enough room to move around and collide, which effectively stops heat transfer in its tracks. Its second superpower is that strange appearance. That smoky blue color isn't a pigment at all. It comes from something called Rayleigh scattering.
The nanoside structures inside the aerogel are so small that they scatter shorter wavelengths of light, like blue, more than longer ones, like red. And this is the exact same reason our sky appears blue. And you can actually make aerogels from more than just silica. By using different metal oxides, scientists can create a whole palette of colors. Aerogels made from iron oxide are a rusty red, while those from chromia are a deep, beautiful green. It just shows you how versatile this material structure really is. So, where is this incredible material actually used? Well, it's gone from the lab to some of the most extreme environments imaginable. The unique properties of aerogel have made it invaluable for everything from space exploration to products we use every day. NASA was one of the first organizations to really harness aerogel's potential. They used it on the Mars Pathfinder rover back in 1997 to insulate its electronics from the brutal Martian cold, and they used it again on the Mars exploration rovers in 2003. But its most famous mission launched in 1999. So the Stardust mission, NASA needed to catch dust particles from a comet. Now these particles were smaller than grains of sand, and they were traveling at 6 times the speed of a rifle bullet. Hitting any normal solid surface would have vaporized them instantly, but when they hit the aerogel, it was like hitting a cloud. The material's porous structure just gently slowed them to a stop, capturing them perfectly intact for their long journey back to Earth. And aerogel isn't just for space. It's making its way into our lives right here on Earth. It's used in high-performance insulation for buildings, in outdoor gear like jackets, and even as a thickening agent in cosmetics. Its porous structure is great for cleaning up oil spills, and its huge surface area makes it a key component in powerful new supercapacitors. Aerogel truly pushes the boundaries of what a solid material can even be. It's a testament to human ingenuity, born from a simple bet and now used to literally catch stardust. It really makes you wonder, if we've already learned how to bottle a cloud, what other impossible materials are just waiting to be discovered?